So we'll discuss these light sensors, that photodiodes. So your photodiodes, the construction of this photodiode is similar to that of your conventional PN junction diode. That you have studied the PN junction diode, that is semiconductor device. So that it is same as that your PN junction diode, except that the diode outer casing is either transparent or has clear lens to focus the light on PN junction for increased sensitivity. So this is, you see that this is the construction of your photodiode. You may have seen these photodiodes. So it is similar to PN junction, only the its mechanical part we can say that its construction is different. That its outer casing is either transparent or has clear lens. Here you can see that here lens is there. You can see that in that picture to focus the light on the PN junction to increase sensitivity. So the junction will respond to light, particularly longer wavelength, such as red and infrared, rather than visible light. So this can be generally used for your uh, that is particularly for longer wavelength, such as red and infrared, rather than your visible light. So we'll see the construction and characteristics of the photodiode. See, this is the construction of your photodiode. This is like your PN junction diode. Here your anode and cathode is there. P and N, that your regions are there. Then the light will be, we can say that it will be put on that particular diode. Okay, and anode, that lens is provided. In that picture also I shown you that lens will be there with that here this particular photodiode. So this is a simple construction. It is same as PN junction, and the lens will be provided with that particular photodiode. So this is the IV characteristics of your photodiode. So this, that characteristics of photodiode with no light on its junction, that is in dark mode, is very similar to normal signal or rectifying diode. So when the photodiode is forward biased, there is an exponential increase in current, the same as for your normal diode. You know that in you have studied the your uh, current voltage characteristics of photodiode, simple PN junction diode. In that also, here there is an exponential increase in current as it is in forward bias. You have studied that the forward bias and the reverse bias of your diode, that characteristics. So when a reverse bias is applied, a small reverse saturation current appears, which will cause an increase of depletion region, which is in sensitive part of the junction. So this is the I will explain this again with the what is the 0 lux and 300 lux. That is that sensitivity is measured in lux. So these photodiodes can also be connected in a current mode using fixed bias voltage across the junction. And the current mode is similar, linear over a wide range. See, this is the current, and this we can say this is the sensitivity. So this is the dark current, and this is fully illuminated. What should be in dark current? Your current at that time of your dark mode, we can say what is your current, and when you are in your fully illuminated, what should be the that particular current. So when used as a light sensor, then the photodiode's dark current, that is 0 lux, is about 100 microampere for germanium. So that material used as silicon or germanium. So here you see that here it is at 0 lux, that is 0 lux sensitivity. Here it is current shown as a 50 microampere. So in the photodiode with no light on its junction, okay. So that is photodiode dark current 0 lux, okay, is about 10 microampere for germanium and 1 microampere for silicon type diodes. So when light falls upon the junction, more holes and electrons pairs are formed and leakage current increases. So this leakage current increases as illumination of junction increases. So here you can see that here, I think this is for the another type material, because at 0 lux it's showing the 50 microampere. Okay, so just remember that this will be the IV characteristics of your photodiode. So when light falls upon your junction, more holes and electron pairs will be formed and leakage current increases. And because of increasing that leakage current, the illumination of junction increases. Thus, photodiode current is directly proportional to light intensity falling on PN junction. So one advantage of this photodiode is that when used as a light sensor, is there fast response to changes in light levels. But one disadvantage is that such type of photo devices is relatively small current flow even when fully illuminated. So there is an advantage also and disadvantage also for this photodiode. That advantage is that when it is used as a light sensor, there fast response to changes in the light level. So this is about the photodiode. It's having the simple construction, like it is like your PN junction and having the one lens is there on the that particular PN junction. So you have to just go to the this construction. What is that photodiode? Then the main IV characteristics of this photodiode. Okay. Next, we will see the phototransistor, and that is the alternate photo device or the photo junction device to your photodiode. Phototransistor, which is basically a photodiode with amplification. Okay, so the phototransistor light sensor has its collector base PN junction reverse bias, exposing it to the radiant light source. So here you see that you have this collector, base, and emitter. The light will be fall on this particular, we can say the base of terminal of your the transistor. Here you see that this is your that particular transistor. One RB register is provided, and with that your photo diode, we can say that photodiode is connected, and VCC is applied. You will get the output V out across your RL. So we can say that this is the alternate photo junction device to your photodiode. So as the name we can say it's having the transistor. As light falls on it, according to that, output of this phototransistor will get changed. It operates at the same as your photodiode, except what they can provide current gain and much more sensitive than photodiode. With currents are 50 to 100 times greater than that of standard photodiode, and any normal transistor can be easily converted into phototransistor light sensor by connecting a photodiode between collector and base. So here it is shown that in between collector and base, one photodiode is connected, okay, in your phototransistor. So this it is having the same function as your photodiode, that phototransistor, only it can provide the current gain and much more sensitive than photodiode. That current is about 50 to 100 times greater than that of standard photodiodes. So this what this phototransistors consist of? It consists of mainly bipolar NPN transistor with its large base region electrically unconnected. Although some phototransistors allow base connection to the sensitivity, and which uses photons of light to generate a base current, which in turn causes collector to emitter current to flow. So this is your NPN type of transistor is there. Okay, and your light will fall on generally on the base region. So this NPN transistor, it's having large base region electrically unconnected. So this phototransistors allows the base connection to control the sensitivity. As light falls on that base region, so that's why that base region, that phototransistor allows that base connection to control the sensitivity, and which uses photons of lights to generate a base current, which in turn causes a collector to emitter to flow. Okay, so these phototransistors are NPN types whose outer casing is either transparent or has a clear lens, like your photodiodes. It is having a that outer casing is maybe transparent, okay, and it's having a lens. Lens is again there with your that particular phototransistor, and focus the light. That lens will be focus the light on the base junction for increased sensitivity. So this is the phototransistor. See, this is the light falling on your optional base region. Collector is there and emitter is there. So here also in this diagram you can see that on base your light will be fall. So this is the IV characteristics of your uh, phototransistor. You can see that it is similar to as you are using your can you say that in which type of configuration it is? So at your zero lux current, that dark current, your this see this your IC. This is the milliampere. That is current is in milliampere. So at zero current, we can say that your output is zero lux. That is sensitivity. At 0.5, your output is 100 lux. At 1 milliampere, output is 300 lux. So it is exponentially increased. So your NPN transistor, the collector is biased positively with respect to emitter. So the base collector junction is reverse bias. Therefore, with no light on the junction, normal leakage or dark current flows, which is very small. So when light falls on the base, more electron hole pairs are formed as like your photodiodes. In that region, the current produced by this action is amplified by the transistor. So this is you have to just see the operation of this NPN transistor. That NPN transistor, your collector is biased positively with respect to the emitter. So your base collector junction is reverse bias, and no light on junction, normal leakage or dark current flows, which is very small. So usually the sensitivity of phototransistor is a function of DC current gain of transistor. So therefore overall sensitivity is a function of collector current and can be controlled by connecting a resistance between base and the emitter. Base and emitter, you can see that here. Base and emitter, this optional, this register is connected, RB register. So this why there is a need of that resistance, because that overall sensitivity is a function of your collector current, and that collector current can be controlled by connecting that resistance. That is just now shown you that RB resistor that is connected across between your base and emitter. Okay, but for very high sensitivity optocoupler type applications, your Darlington phototransistors are generally used. So whenever for your high sensitivity, okay, to measure the high sensitivity optocoupler type applications, your Darlington phototransistors are used. So this single NPN transistor, with the help of that you can make a Darlington pair of that phototransistor, and that will be connected in the circuitry. Okay, so that is for your very high sensitivity, that actually that Darlington pair will be used, because it is used to sense the applications of phototransistors. The typical applications of phototransistors light sensors are in opto isolators, then slotted opto switches, light beam sensors, fiber optics, and TV type remote controls. You may have seen the remote control of your TV. If you open that, you can see that photo transistors may be there sometimes in that remote control. Infrared filters are sometimes required when detecting visible light. Okay, so generally these are used for the red and infrared lights, these photodiodes and phototransistors. Next, one more type, that photovoltaic cells. The most common type of photovoltaic light sensor is your solar cell. You may have seen that solar cell. So what it will do, that solar cells that will uh, convert light energy directly into DC electrical signal in the form of voltage or current. Okay. So in general, we can say solar cells means your solar panels nowadays coming. Okay. So that solar cells, they will convert your light energy, that your sunlight, we can say, into the directly into DC electrical energy in the form of voltage or current to a power resistive load such as light, battery or motor. So you can charge your battery with the help of these solar cells. Then photovoltaic cells are similar in many ways to a battery because they supply the DC power. They are used in many different types of applications to offer alternate power source from conventional batteries, such as calculators, satellite, and now in home offering a form of renewable power. So you all of you know that nowadays that solar panels are now in use. Okay, so that solar panels directly will get converted into the electrical form. So yeah, at your home also, if you have seen your solar panels, you see the connections of that, how it will be converted that light into the electrical energy, and then how it will be utilized for the further application. So, what is that photovoltaic cells? Actually, they are made from single crystal silicon PN junction, that is same as photodiodes, with very large light sensitivity region, but are used without the reverse bias. So they have the same characteristics as very large photodiode when in the dark. So when these solar cells that will be in a dark mode, so they are having the same characteristics as your photodiodes. And when illuminated, that means if the light will falls on that, then that illuminated the light energy causes electrons to flow through PN junction, and individual solar cell can generate an open circuit voltage of 0.58 volts, that is 580 millivolts. So if anybody is using these solar panels in your project, so you should have to first clear about this. What is that solar cells? So that solar cells are nothing but your PN junction diodes only. They have the same as the in the dark region. But when the light will be illuminated or the light will be fall on that, then that light energy will cause electrons to flow through the PN junction, and individual solar cell, if you see the solar panel, there are different solar cells on that. So that solar cell, single solar cell can generate an open circuit voltage of about 0.58 volt. That means 580 millivolt. So solar cell have positive and negative side just like a battery. So it's like your battery. Just now I told you that it will be provide you the DC power supply. Okay. So individual solar cell can connect it together in series to form solar panels, which increase the output voltage, or connected together in parallel to increase the available current. Series, then that increases the output voltage. Or if you connect it together in parallel, then to increase the available current. Okay, so in these two way, that solar cells will be connected in the solar panel. So commercially available solar panels are rated in watts, which is the product of output voltage into current, volts times ampere, when fully illuminated. See, this is the single solar cell. This sunlight will be fall on that, okay, and it will produce the 0.58 volt output voltage, okay, and this is the characteristics of that particular solar cell, photovoltaic solar cell. This is the current and this is the voltage. So you see that how that current and voltage has the proportionate. So the amount of available current from solar cell depends upon light intensity, the size of cell and its efficiency, which is generally very low at around 15 to 20%. Okay, so the you should have to remember the how the efficiency of that particular solar cells will be there. To increase the overall efficiency of cell, commercially available solar cells use polycrystalline silicon or amorphous silicon, which have no crystalline structure and can generate current of between 20 to 40 milliampere per square meter, centimeter square. Okay, so that area of that solar panel, you should have to consider that also. Okay, so to increase the overall efficiency of that cells commercially, so solar cells, what they usually use the photocrystalline silicon, that material, or amorphous silicon, anyone will be there, and which have no crystalline structure, and that generates the current of between 20 to 40 milliampere per centimeter square. The material used in construction of these photovoltaic cells include gallium arsenide, copper, indium diselenide, and cadmium telluride. Okay, so these materials also there in your photovoltaic cells. Uh, Instead of that silicon, can use gallium arsenide or copper, indium diselenide, or cadmium telluride. So these different materials each have different spectrum band response, and so can be tuned to produce an output voltage at different wavelength of light. So this is about your photovoltaic cells, that is the solar cells. You can see the structure of your solar panels. Okay, nowadays you are uh, seeing that the that solar panels are everywhere on the buildings there. If you go in agriculture, there also you can see that solar panels. Okay, but try to understand what should be there in that solar panels. So your solar panels are having your these solar cells, and how they are connected, that solar cells in may be connected in series, or they may be connected in a parallel. Okay, so this all about the light sensor. You can go through the number of light sensors are available. So whatever generally are there in labs also, or you may have seen easily, that photodiodes, LDR, then your phototransistors, and these solar cells. Nowadays only these solar cells will be in used more. Okay, so this is all about light sensors. Now we'll go to the next part, that is the liquid level sensors. Can you tell me where you are seeing these liquid level sensors? Any example of this liquid level sensors? Yes, Hitesh, Shubham, anybody can tell me liquid level sensor in your daily routines. If you have that unit with your uh, home, then you can tell that, or in general also you can tell that where you have find these liquid level sensors. Hmm? Poonam, Rutuja, Varsha, आहेत ना सगळे?
Yes, ma'am.
हम्म. कुठे बघितलंय लिक्विड लेवल सेन्सर? It's very simple example. In AquaGuard. No, in AquaGuard it's not there. Oil tankers. Okay. Any more to check the level? Water level management system. Okay, correct. Water level tanks. Yes. Any more example or application? Water level indicator. Hmm. In industrial areas, any example? Hitesh has told about the oil tank. Any more example? Float sensor. That is the example of water level sensor. Hitesh, you told me that it is used in the Indian oil tankers, okay, to check the level. But from where that tankers will get filled? Anybody knows that? औरंगाबाद साईडला कोणी राहतं का? हो ना, ते फील होतात. पण ते कुठून फील करता तुम्ही? From where you can feel that? So this is the liquid level sensors. They are termed as the sensors used for detecting liquid levels or interfaces between liquids such as water and oil or solids and liquids. So you can measure the level of your water also, your oil also. Okay. So these sensors can also be defined as transducers or integrated systems with instrumentation and control capabilities. So this type of liquid sensor is one of the most important sensor and plays a vital role in variety of industrial and consumer applications. So in industry also there is the use of these level sensors, liquid level sensors. So in your industrial applications that includes liquid level sensing in transport tanks. Just now Hitesh told me the example of that, your transport tank, then storage tanks, water treatment tanks that are also used, water treatment tanks, and also in petrochemical industries. Just now I told you that example of this petrochemical industries for sensing liquids such as petrol, diesel, and other fuels. So this liquid level measurement is significant in household applications, including electronic devices. You may have seen at your homes also, in your buildings, if that unit is there, that in your water tank, that you have the two tanks that is below your building and one tank will be on the top of your building. If you want to fill your tank that is on the top, okay, so you will on the motor from the bottom tank, that water will go to the uh, top of your that tank. Okay, so that sensors will be there in your bottom tank. They will sense the level of that particular tank. If that will be getting over, then that particular indicator will be there on the, that if you have that unit installed at your building, then you can see that three buttons, three lights will be there for the level of that particular water in the tank. That is for your low level, medium level, and the high level. That is, if your tank will get full, then it will particular, that one LED will glow. If it is at medium level, then that particular LED will glow, and if it is at low level, then that what the particular LED will be assigned for that, then that will be get glow. So that sensors will be there in that particular tanks. So that your household applications, including your electronic devices such as water dispensers, water evaporators, steamers, monitoring system of boilers. In your sugar factories, these boilers are there. Okay, so you can see the boilers, that level in that boilers, liquid level, you can measure that. Then your heating systems, washing machines, steam irons, juice squeezers, automated coffee machines. In every these are the examples of your liquid level measurement. So your level sensors are designed for specific applications compared to general applications. Now the classification of level sensors measuring systems is classified in different categories, such as first liquid or solid level measurement. This is the one type of your level sensor measurement system. Then second, point or continuous level measurement. Then next is electromagnetic or electromechanical level measurement. And last, contacting or non-contacting level measurement. So these are the classification of your level sensor measuring system. Okay. So generally, what we should have to consider for this level sensor selection. Okay, how you can select that particular liquid level sensor? So you should have to consider these parameters for that particular liquid level sensor. So first is density and viscosity of that particular level sensor. Then vapor, mist and dust, chemical composition, interfaces and gradients, ambient temperature, humidity or moisture, then process temperature, process pressure, and regulated environment. So all these parameters one should has to consider while selecting that particular liquid level sensor. Okay, so uh, this again this liquid level switch measurement and detection system. The in that the sensors are used for purpose of marking a single liquid height or for presenting a level condition. So usually this sensor work as a high alarm that measures the overflow conditions in tank through liquid level sensors, or work as a marker to note down the low alarm levels. As I told you that example of your water tank at your in your home, if you have that. Okay, the marking will be there that alarm will get on and that particular condition. So there are different types of sensors. So these three sensors we will study in details. That is the first is the float sensor, capacitance sensors, and conductivity probe. So you should know what should be there in the flow sensors, or what should be there in capacitance sensors and conductivity probe. So this will be discussed. We will discuss this